right, ladies and gentlemen, we are looking at 6.3. We are looking at 6.3, similar polygons. When there is a correspondence between two polygons, such that their corresponding angles are congruent. What are corresponding angles again? So if we have a polygon, so let's just make up a square, or a four-sided figure of some sort. Corresponding angles are angles that are in the same position. So these would be corresponding angles. Okay? Are congruent, and the length of corresponding sides are proportional. Sides are proportional. Now we talked about that. We did that with a whole calculator activity, figuring out that the triangle's sides are proportional. Okay? Meaning they have the same ratio. You need to get up and write this down. David, please put your head up. Okay. Theorem 6.1, if two polygons are similar, then the ratios of the perimeter is equal to the ratios of the corresponding sides. So if they are similar, then their perimeter ratio is the same as their side ratio. What's a perimeter again?
Like the outside side up.
It's like walking around the outside, adding that all up. Yes. Okay. Similar polygons we're going to do now. Okay, you do need more vocab sheets. That's why Mr. Van Horsen is handing it out to you. Okay, let's look. Two polygons are similar. List all the pairs of congruent angles. Write the ratios of the corresponding sides in statement of proportionality. Okay, so I can hear your music, so it needs to be turned off now. I do not need to hear it again. I can hear your music. You need to have it turned off. Okay, so we're looking, Andrea, take them out of your ears, turn the music off. Okay, letter A, what angles are congruent? What is congruent to angle A? Angle L. What is congruent to angle B? Angle M. What is congruent to angle C then? Angle N. Okay, now we have to set up our ratio. So if we have side AB, which side would AB match? LM. So they have a ratio which is equal to BC over NM, which would equal AC over I think actually these are wrong. This should be LN and this should be LM. Was that what you were going to say, Dana?
Yeah.
And when we write that angles are proportional, are similar, we have ABC, so we have triangle ABC. Instead of the congruent, we just use the top part. We say similar to triangle LMN. Okay, so let's look at one more. Let's skip B, let's go to C, because I don't think we need to do all of them, right? This looks a little complicated, but what angles are congruent to each other? We've got angle E.
Congruent to Q.
Is it?
M.
Wait.
I think it's M. I think it's angle M. Angle F is congruent to what?
Angle F is congruent to R.
R. Angle G is congruent to angle
Q.
Q. Angle H to angle P. And angle J to angle N. Okay. Now we have to do the whole proportionality thing. So let's see. We've got EF over MR. We've got FG to RQ. We've got GH to QP.
What's the bottom one?
J. When the record is on, sometimes it makes things funny. GHQP, HJPN, and there's one more. We've got JE and NM.
Now, how are you figuring these out again? Because I'm getting lost.
Okay, no problem. So, we're looking at EF, which is right here, right? Now I'm like, okay, which angles go with E and F? Well, I set up the angles. That was okay, right? So I'm like, oh, well, it must be MR. Those must be proportional to each other. Does that help? And then I'm looking at FG, right? So I'm looking at FG, this line right here. So I'm like, okay, what goes with FG? R and Q.
Oh, overlapping. So I thought you were doing like just like.
Because we're not looking at the angles, we're looking at the sides. So we know it's from 2 points to 2 points. Okay? So let's make these triangles congruent, similar to each other. Not triangles, polygons. So we'll just list these. So we go polygon E, F, G, H, J is similar to, and then we list it just in the order right here. M, R, Q, P, N. Okay. Let's go to example 2. Let's figure out if these polygons are similar. All right. We've got some polygons, and we've got to decide if they're similar. What do we know about similar polygons? They all have to have congruent corresponding angles, and they have to have proportional sides. Okay, so let's see. It shows me right here that angle A is congruent to angle Y. Excuse me. We're shown that angle B and angle X are congruent. That means, right, that C and Z have to be congruent, right? What do we call that third angle theorem? Okay, now we have to set up some proportionality stuff. Okay, let's look here. What side is proportional, is corresponding, so we can see if it's proportional, to AB?
XY.
XY. So I'm going to take 9/3. Okay, so let's see. What about B to C? What would be corresponding from B to C? X to Z. So that's 12/4. See how I'm always putting the big one over the little one? It doesn't matter as long as it's always big over little or always little over big. Okay. And next we've got A to C, which is corresponding to Z to Y. Now we've just got to see if all of those divide to give me the same thing. What's 9 divided by 3?
3.
What's 12 divided by 3?
3.
Yeah, 4 goes into 12 3 times. What's 15 divided by 5?
3.
That doesn't even look like a 5.
Look at 8.
It gives me 3. So these are all proportional. So yes, they are similar. Should we try another one? Okay. So the first question you're asking in your head, are all the corresponding angles congruent? Are all the corresponding angles congruent? Are they?
Yes.
Yes. Okay, so now we have to see if the corresponding sides are proportional. How many different numbers are up there for the sides?
4.
2. So I can say, okay, let's look at A to B. That's 8. What is the corresponding side for AB?
TQ.
TQ. Okay, let's do one more, because then we know the other two are correct. We have BC is 10. What's the corresponding side for BC?
8.
What letters?
Oh, QR.
QR, which is 8. Okay, so let's reduce these and see what we got. What goes into both 8 and 6 evenly? 2. So we have 4 over 3. What goes into 10 and 8 evenly? 2. So we get 5 and 4. Do those match? No, not similar. And why are they not similar? Because they're not proportional. Not proportional. All right, let's look at scale factor.
Oh, no.
Okay. We're going to list all the pairs of congruent angles and write the statements of proportionality for the polygon. Okay, so first of all, let's list all the angles because I think those are easiest. Oop, this is D, C. Okay, so what do we want to start with? What angle? Angle V. Angle V is congruent to what angle?
Angle C.
Angle C. Angle U is congruent to what angle? B. Angle T is congruent to A. And angle W is congruent to D. Okay, so let's set up some proportions. I know what two corresponding sides have numbers?
TU with AB and WV.
TU and AB are the only ones that both have numbers and they're corresponding. Okay, so I know I'm going to have TU over AB, which is 15 over 9. Can I reduce that fraction?
No. Yes.
Yeah, what do I reduce it to?
5 over 3.
5 over 3. Oops. Oh, I love my computer so much. Okay. So when we find the scale factor from A, B, C, D to T, U, V, W, so when I go from the big one to the little one, what do I do? Do I times it by 5 and divide it by 3? Would that work? 15 times 5 divided by 3. 15 times 5 divided by 3. Would that give me 9? What would I do? 15 times 3 is what?
45, 45.
Divided by 5 is 9. So I'm going to go 3 times 5. Okay, now if I'm going from the little one to the big one, what would I do?
What is that?
3 over 5. That's my scale factor. I times it by 3, divide by 5. Okay, what if I'm going from the big one to the little one?
Divide.
Oops, this is in the wrong order. Sorry. This would be 5 over 3 because I'm going from the little one to the big one. This is from the big one to the little one. So now I want to find the length of TW. So I know AB. Okay, I know A to D is 6. I want to find the big length. So I'm going from the little one to the big one. Which one goes from the little one to the big one? The first one or the second one?
First one.
First one. So I cross multiply. 3 times 6 is 18, which equals 5x. Divide both sides by 5. 5 goes into 18 3 times with 3/5 left over. Is that right?